All right, kiddies, we are going to walk through the hierarchy of numbers. Everything you're going to see on this slide is a real number. Now, the natural numbers, these are the ones you are familiar with counting by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, on and on, forever and ever, as high as you want to go. Those are the natural numbers. The whole numbers are all of the natural numbers, so everything in this box, including 0. So the whole numbers are everything that live inside this slightly larger box. 0, 1, 2, 3, 4, 5, 6, 7, on up to infinity. Now, the integers. The integers are everything inside this next box. They are, let's see, how can I write? They are all the negative numbers. So everything that comes up negative, like this. And they go on and on. But, so the integers are all of the negative numbers, 0, and all of the positive numbers. So the integers include 0 and the positive numbers. I've just already written them down here in these boxes. So natural numbers, the counting numbers. Whole numbers, counting numbers and 0. Integers, counting numbers, 0, and all of the negatives or the opposites of the counting numbers. The next level is the rational numbers. And this is any number that takes the form a over b, where b is not equal to 0. That's a very mathematical way to say any fraction, positive or negative, written as a decimal, a percentage, or a fraction. So we could have any one of these numbers is a rational number. We could throw in here, how about 25% also. With rational numbers, I just want you to think fractions, decimals, and percents. Fractions, decimals, and percents. Those are the rational numbers. And included within the rational numbers are the integers, the whole numbers, and the natural numbers. Now, last but not least, within the set of real numbers are the irrational numbers. The irrational numbers are a special type of decimal that does not have a terminating point and does not repeat. So it's a decimal number with no terminating point and no repeating pattern. It's just different decimal numbers on and on and on forever without any termination and without any repeating pattern. The most famous of these is pi, which we approximate as 3.14159, but there's an infinite number of digits that follow that 9, and there are no repeating patterns within that infinite set. Another very famous irrational number is Euler's number, which we estimate as 2.7182, but again, it goes on and on forever without any repeating pattern. Another very famous irrational number is phi, which we can estimate as 1.61083. But this number again continues on and on and on. Different decimal numbers, different digits forever and ever without any repeating patterns and without any terminating point. Other irrational numbers you'll get to know are square roots that are not perfect squares. The square root of 2, which is about 1.41421, but continues on without repeating and without terminating. There's a square root of 3, which is approximately something. There is a square root of 5, square root of 7. Anything that's not a perfect square, that is an irrational number that lives in this column over here. Now, it's important to understand that while the irrational numbers are real numbers, they are completely separate from the rationals, the integers, the whole numbers, and the natural numbers. These are decimals that don't repeat and they don't terminate, so they cannot be represented as a fraction.